I'm Don Smith, and I'll be presenting the Sub-1 GHz technical introduction, including a video demonstration of the Performance Line kit and tools. Why would you choose Sub-1 GHz for your application? The main reason to choose Sub-1 GHz over, for example, 2.4 GHz is the longer range. Due to the physical properties of Sub-1 GHz frequencies, the radio range can be up to several kilometers. New technology in the integrated RF transceivers from TI also makes the communication more robust and reliable. If you look at the market trend today and 5 to 10 years into the future, the problem of interference will dramatically increase as the number of RF devices grows. Our Performance Line offers the best-in-class coexistence and range, which means you don't have to worry about field returns and redesigning your product in the future. For Sub-1 GHz, you have license-free ISM bands available worldwide that allow wireless data communication without the need for subscription or fees. There are, however, variations in the RF regulations in different regions, typically making it necessary to have different design variations for the different regions. TI's Sub-1 GHz radio devices are designed for ultra-low power and are widely used in low-power nodes that last up to 15 years on small lithium cells. For Sub-1 GHz, we concentrate on three main application areas. These are metering and smart grid, alarm and security, automation. For metering and smart grid, the main application is remote meter reading. Here, the meter data is transferred from the meter to a concentrator and to the back office. A typical requirement for these applications is 15 years battery lifetime. The longer range, the fewer concentrators are needed, hence reducing total system cost. Alarm and security systems and home automation systems typically have similar requirements. Customers choose Sub-1 GHz RF technology to guarantee full house coverage in a star network topology. The star network enable power-efficient and low-cost networks with small MCUs. When doing an RF design, you need to decide what frequency band to use. As shown on this map, different regions have different regulations for industrial, scientific, and medical bands. These ISM bands are license-free, and TI provides solutions for all. Commonly used Sub-1 GHz bands are around 900 MHz, Europe 868 MHz, the US 915 MHz, Japan 920 MHz, and all can be served by the same hardware printed circuit board. 433 MHz is also popular and can be used worldwide. Please remember that all RF-enabled end products must pass mandatory regional certification programs. Let's start with power consumption. First off, a quick startup and fast-settling receiver minimizes the power consumption. On the top of this slide, you can see a competitor device. Here, the radio must stay and receive continuously to make sure the transmitted packet is received, settling the receiver during the preamble. On the bottom half of the slide is our Performance Line with the ultra-fast wave match receiver. The fast-settling receiver can automatically duty cycle receive to greatly reduce average power consumption when searching for packets without sacrificing RF performance. We have discussed power consumption. Let's dive in further on understanding range and coexistence. There are several factors that influence range. Two key factors are sensitivity and output power. Shown on this slide is a single communication system with one TX transmitter and one RX receiver. To increase the range, you can increase the output power. Please note the maximum output power is limited by regional RF regulations. Another way to improve the range is to increase the sensitivity. The sensitivity is influenced by many factors, but the two most important are data rate and receiver sensitivity. Typically, a higher data rate gives the shorter range, so it is important to find a data rate that fits the range and throughput requirements. The receiver sensitivity is the ability to decode an incoming RF signal. Given the same data rate, a good receiver is able to decode a weaker signal, which will give you a better range. I'll give you an example. Around 50 kilobits per second will typically give full house coverage and a good balance between throughput and range for an alarm and security system. The example here is not a realistic field scenario. In real life, you will have interference. Interference can severely limit communication range of your system. To successfully operate in a hostile RF environment, you need really good coexisting properties. This translates to first-pass installation success. The coexisting properties of a device is defined by the selectivity and blocking performance. It is important to understand that better selectivity and blocking translates directly to better sensitivity and range in the presence of interference. This will be explained in detail on the next slide. Let's look at what coexistence means in an everyday environment, using a smart meter network as an example. To the left, you see a system based on the TI Sub-1GHz performance line. To the right, you see a system based on a competitor device. The green dot represents data collectors. The yellow dots represent smart meters. Let's look at what happens if an interferer device enters the environment. In this example, let's assume a wireless headset. The wireless headset interferes with the range of the data collector, making it impossible to communicate with the far-out nodes. Since the data collector range is reduced, you will need more data collectors to have the same coverage area, and also, if this is temporary interference, you will get higher packet loss and will need more retransmissions. Let's look at what happens in the same example using the system based on the TI Sub-1GHz performance line. The wireless headset enters the environment, but the range is not affected. The data collector maintains the range, meaning you can have less data collectors, longer range, and fewer retransmissions. Let's look at a video demonstrating more than 10 kilometers of range out of the box with a standard CC1120 development kit.
Hi, today we're going to demonstrate the range of the CC1120 Performance Line radio. My name is Magnus Vinnes and I'm heading the tools development team in Texas Instruments Low Power RF. Today we're standing on top of Holmenkollen ski jump in Oslo, and my colleague is standing on the other side of Oslo. This is the board that you find in this Performance Line development kit. I have configured the radio to transmit packets, and my colleague will now receive the packets on the other side. So over to Erling.
Thank you, Magnus. My name is Erling Simonsen. We are doing a range test here, and I'm receiving packets from the Holmenkollen ski jump down to the Viking Ship Museum here by the Oslo Fjord. The distance between these 2 points is around 7 kilometers, and I have around 30 dB of link margin left using the RF Performance Line development kit with CC1120. And unfortunately I can't go any further because then I would have to swim. So if you want more than 10 kilometers of RF range, get the RF Performance Line development kit with CC1120. Go to ti.com/RF Performance Line. Thank you for watching.
To get range and coexistence, you will need to consider all aspects of an RF design. At TI, we have more than 15 years of RF experience and offer you a complete system solution. This includes hardware, reference designs, tools, and software. On this slide, we show our hardware offering. We have two main families of RF devices, Performance Line and Value Line. In addition, we have a range extender and system on chips. To support these, we have a comprehensive offering of development kits. Here are listed the most relevant ones. Please note we have an antenna selection guide to help you, since this is a critical part in an RF design. To speed up the design process, we offer several tools for development and debugging. Our main tool is Smart RF Studio. Smart RF Studio allows you to configure RF settings and evaluate the performance. Through Smart RF Studio, you can easily export your RF settings to any MCU, for example, an MSP430. You can also easily export the settings to set up our free packet sniffer. The packet sniffer allows you to see RF communication over the air, which simplifies debugging. For fast and convenient support, we have a very active E2E community with a wide knowledge database. This database has been growing since 2008, and you will find answers to most of your RF-related questions or get help from one of our factory experts. With more than 15 years of RF experience, we have a comprehensive library of reference designs, application, and design notes. They cover all aspects of creating an RF design and will help you in getting the best range and coexistence for your application. The sub-1 GHz market today is dominated by proprietary and legacy systems. Due to the differences in regional regulations, standardization on sub-1 GHz has been slow. Our RF devices offer full flexibility on all RF parameters to enable support for all types of legacy systems, from simple garage door openers to high-performance long-range metering applications. We have basic software examples that can be used as a starting point, including EasyLink, to set up simple communication between RF nodes and a packet error rate tester to easily evaluate range. The Simplicity-I software stack is a star network that is offered in source code that can be used as is, or as a starting point for development. Simplicity-I is available and free for all TI LPRF devices. For Europe, Wireless M-Bus is a popular communication stack for metering, and KNX is a home automation stack. 6LoWPAN is a new RF technology defining IPv6 packets on a low-power RF network. It is typically referred to as enabling mesh communication for both sub-1 GHz and 2.4 GHz. We offer 6LoWPAN solutions in collaboration with third parties. Our current sub-1 GHz offering includes the Value Line family of devices and the Performance Line family of devices. The CC1200 and CC1201 are the newest members of the Performance Line family, bringing you higher data rates up to 1 megabit per second, and hardware AES security. CC1200 and CC1201 also have hardware features to support the new 6LoWPAN technology. Our cost-effective SoCs, CC1110 and CC1111, offers CC1101 RF technology with an 8051 MCU core, and the CC430 offers the same RF technology with the MSP430 core. TI's sub-1 GHz RF technology has the best range and coexistence in the industry. This is important for three main reasons. Fewer nodes are needed for your network, a more reliable RF link, and fewer retransmissions. This creates a lower overall system cost to you, a more robust solution, and longer battery life. To elaborate on the longer battery life, we are seeing sub 3 mA average RX current, allowing for years on one battery, shorter startup times, and higher noise immune system, meaning no false system wake-ups that can waste your customers' batteries. Lastly, when using TI's sub-1 GHz technology, you also receive over 15 years of RF experience through our tools and support. We have listed some frequently asked questions. You can read our answers to the right. What range can I expect in an indoor environment? What is the longest range I can get? How can I test coexistence? How can I reduce power consumption? There are some initial design considerations we believe are important to think about. We have listed some questions, and you can read our answers to the right. What device should I choose for my application? What tools do I need? What frequency band should I choose? Should I use modules or make my own design? Here you can see where to find more information and training on sub-1 GHz. I want to address our technical trainings to be found on TI Training Center. Please take a look at them. Thank you for your attention. Please do not hesitate to contact us at any time. For our TI colleagues only, we have an overview of our competition. Use this information to understand your competition better. and our strengths against them. The main three competitors in the performance-focused sub-1 GHz market is Silicon Labs, Semtech, and quite recently also ST. Other players are Analog Device and Atmel. RF products are quite complicated, and customers can have very different opinions in terms of what is important. For customers with a stronger power consumption focus, be sure to focus on the sniff mode metrics. Lastly, every month we send out an internal update of our key design ends, our RTMs, and useful information on what is going on for WCS. If you would like to receive it, please contact Volker Preller or Marianne Sturman to be added to the list. Here is a list of our product marketing and business development teams. Please do not hesitate to contact us at any time. Thank you for your attention.